Now, Patrick Moore invites us on another excursion into the sky at night.
Good evening. A very interesting picture has been received from the Hubble Space Telescope. It's of the giant galaxy M87, and it shows a jet coming out of the galaxy's nucleus, distance 50 million miles. And it may well be that that jet is powered by an immense black hole. It is certainly a spectacular picture, and it shows yet again that, in spite of its faulty mirror, there are many ways in which the Hubble telescope can still outperform any Earth-based instrument. You may remember that some time ago we presented a program in which astronomers using the Jodrell Bank radio telescope described the discovery of a planet orbiting a pulsar or neutron star. Well, it's now been found that that planet does not exist. There had been a mistake, and it's very greatly to the credit of the astronomers that as soon as they realized that an error had been made, they made a very full statement about it. There's mixed news about the various spacecraft. Magellan is still orbiting Venus, still working quite well, and sending back excellent results. Look, for example, at that whole disk. And I particularly like this view of a Venus volcano, Sapas Mons, with a 250-mile base and a height of 1 mile. You can see those two craters in the top. Whether that volcano is still active, we don't know, but it could well be. And we hope now that Magellan will go on operating until the end of the year. But I'm afraid things aren't so good with the Jupiter probe, Galileo, which should reach Jupiter in 1995. The problem there is that the high-gain antenna, that you can see on the top of the spacecraft there, has not deployed properly. Efforts are being made to free it, but unless they're successful, I'm afraid we're not going to get back very much from Jupiter. But all the same, Galileo has sent back the first really good close-range picture of an asteroid or minor planet, Gaspra. There it is, a strange potato-shaped little world, less than 20 miles long. And I must say that our program next month is going to be all about asteroids in general. The other real success story is Ulysses, which is scheduled to explore the poles of the sun. To do that, it has to go right out of the ecliptic. And the way to do that is to use the gravitational pull of giant Jupiter. And this was done because on the 8th of February, Ulysses passed over Jupiter's north pole. And the pull of the planet slung it into an orbit, taking it well away from the ecliptic. And that means it can survey the south pole of the sun in 1994, and the north pole of the sun in 1995. And that's very important because we don't know much about the solar poles. We've always seen the sun broadside on, so to speak. And I think that over the next few years, Ulysses is going to tell us a great deal. And now, on to my main theme for tonight. I want to talk about what you can see in the night sky with binoculars. Because I think, in my view anyway, binoculars are a great deal better than a very small telescope. And if you're going to get one pair, I would say that the ideal is something like 7 by 50. That means a magnification of 7 with each object glass 50 millimeters in diameter. And with those you can see a great deal. Moreover, it doesn't take long to find your way around the sky. And the thing to do is to use various sky markers. And one of the best is Orion, the hunter, now high up in the south after dark. And you can't mistake Orion with his 2 brilliant leaders and the starry belt and the misty sword. The 2 brightest stars are very different. They are Betelgeuse and Rigel. And even with the naked eye, you can see they're different in color. That's because Betelgeuse is the cooler of the 2. Rigel is a brilliant white star, something like 60,000 sun power, and highly luminous. Betelgeuse isn't so luminous as that, but it can still match 15,000 suns, and as you can see, it is decidedly orange-red. It's also slightly variable, and at the moment, it's almost as brilliant as it can ever get, although even so, it can't quite match Rigel. Now, Betelgeuse, then, has a cool surface, but to make up for that, it is vast. The Earth is 93 million miles from the Sun, and so the diameter of the Earth's orbit is nearly 200 million miles. The huge globe of Betelgeuse could fill that completely, so it really does merit its title of a red supergiant. Now, coming back to Orion, this time, look below the 3 stars of the Hunter's Belt. And there you will see the sword, and in the middle of that is the nebula M42. M, by the way, stands for Messier, the French astronomer who catalogued clusters of nebulae way back in 1781, and we still use his numbers. Now, M42 is a gaseous nebula. In this picture, you can see the belt stars at the top, and there, just below the center of the picture, is the nebula. And if you have a telescope, then you can see the stars of the so-called trapezium, which light up the nebula and make it shine. Inside that nebula, fresh stars are being created from the nebular material. But although the nebula is very large, and well over 1,000 light years away, it's not very dense. In fact, if I could take a core the size of an egg cup and go right to the nebula from one side to the other, by the time I came out, I would have collected just about enough nebular material to balance the weight of 1 pound coin, which is not very much. But do have a look at M42. It really is a superb sight. Now, coming back to Orion, follow the stars of the belt downwards. And there you come to Sirius in Canis Major, the great dog. And that is the brightest star in the sky. Actually, it looks so brilliant because it is comparatively near. It's only 8.5 light years away, which is roughly 50 million miles, which of course is very much closer than either Rigel or Betelgeuse. And Sirius is pure white. But if you look at it, and particularly with binoculars, you will see that it twinkles violently and seems to flash various colors of the rainbow. Star twinkling has nothing directly to do with the stars themselves. It's purely due to the Earth's atmosphere. And the less atmosphere we look through, the less the star twinkles. For example, consider two stars, one high up. And you can see from that diagram that the light comes to us through a fairly shallow layer of atmosphere. If, on the other hand, to your observer, the star is lower down, then the light has to come through a much deeper layer of atmosphere, and it twinkles more. And Sirius shows that particularly, partly because it is so brilliant, and partly because, from here, it's never very high up. Because I'm not saying that the star directly overhead won't twinkle. Of course it will, but the higher up it is, the less it will twinkle. Canis Major is a large constellation, contains some interesting things. There is, for example, an open cluster, M41, not very far from Sirius, quite easily visible with the naked eye, and well shown in binoculars. It's a typical open cluster, and we believe that the stars in it had a common origin, born out of the same mass of nebular material. And most of the stars in M41 are very hot and bluish-white, so they're considerably younger than our yellow sun. Orion, as I say, is a splendid marker. Now let's view the stars of the belt upwards. And this time we come to Aldebaran in Taurus the bull, and because Aldebaran's red, it's often known as the eye of the bull. It's about the same color as Betelgeuse, not so bright and not so luminous. But extending away from Aldebaran to the right-hand side, you will see a little V formation of stars, and they make up the Hyades. And the first star below Aldebaran in that V is called Theta Tauri. I'll have more to say about that in a minute. And there, in fact, is a picture of the Hyades. But oddly enough, Aldebaran is not a genuine member of the Hyades at all. It merely lies in the same direction, and therefore it appears to be in the cluster, whereas in fact it isn't, only about half the distance. This is the view from the Earth. Now let's, in imagination, move ourselves away and have a look from a different direction. And as you can see, Aldebaran is no longer even apparently inside the cluster. In a way, I think it's rather a pity it's there, because it rather drowns the Hyades. But I mentioned Theta Tauri just now. You can see with the naked eye that it's double. And if you use binoculars, you will see that those two components are of different colors. One is pure white, and the other is yellowish-orange, and it really makes rather a nice contrast. The Hyades are interesting, but beyond them, we come to the most famous star cluster in the sky, the Pleiades, or Seven Sisters. And you can't possibly mistake the Pleiades. With the naked eye, at first they look like a kind of tiny haze, but then you can see individual stars. And I always think that binoculars give the best view of them, because you can get all the cluster in the field of view at once. And once you start using a telescope, you will see many more stars, of course, but you won't get the entire cluster in the field at the same time. So in my view, for the Pleiades, binoculars are best. You know, something like 30 years ago, I did a Sky at Night program in which I asked people to tell me how many stars in the Pleiades they could see with the naked eye on a clear, dark night. And the average was indeed 7, but some people could do better, and I believe the record is about 19. So next time the sky is really dark and clear, have a look at the Hyades and see how many stars you can count. If you get as far as 9 or 10, you're doing very well indeed. Another constellation in Orion's retinue is Gemini, the twins. In mythology, the twins, Castor and Pollux, were twin boys. Pollux was immortal, Castor wasn't. When Castor was killed, Pollux pleaded to be allowed to share his immortality with his brother, and both were placed in the sky. Quite a nice little story. But interestingly, in ancient times, Castor was regarded as the brighter of the two. Well, now, Pollux is the brighter by about half a magnitude. Whether there's been any real change, I don't know. But anyway, there are different colours, and your binoculars bring that out very well indeed. Castor is white, and Pollux, again, is kind of yellowish-orange. The rest of Gemini consists of long lines of stars spreading down in the general direction of Betelgeuse. And in the constellation, we find one very good open cluster, M35, near the two ready stars, Eta and Mu Geminorum. And again, a naked eye object. Binoculars showed it well. There it is to the upper left-hand side of the picture. Quite a nice open cluster. But there is a better one in the rather obscure constellation of Cancer, the crab, which lies between the twins on one side and Leo, the lion, on the other. And this cluster is called Praesepe, M44, often nicknamed the manger or the beehive, although for some reason I've never fathomed, the old Chinese used to call it the exhalation of piled-up corpses. Don't like that very much. But it's a nice, spectacular cluster, and binoculars give a very good view of it indeed. It's not the only cluster in Cancer. There's another good open cluster, M67, and this lies near the fourth magnitude star, Acubens, or Alpha Cancri. Again, just about visible with the naked eye. I'm never quite sure I can see it, and binoculars show it well. And it's interesting because although most open clusters seem to be young, because they are pulled about and broken up by the gravitational tugs of other stars, M67 lies well away from the main plane of the galaxy and appears to be comparatively old, and in that respect is very interesting indeed. Look almost straight overhead in the evening, and you will see the brilliant yellow star Capella, and that's the leader of Auriga, the charioteer. And Capella is, in fact, a yellow star like the Sun, but considerably more powerful. And in fact, it's a very close binary star, although with ordinary telescopes it appears single. But look to the right of Capella, and you will see a little triangle of stars, and they're known as the Kids. And the star at the apex of that triangle, which is called Epsilon Aurigui, is a very interesting kid indeed. With binoculars, it looks like an ordinary star. You can see it there below Capella, at the top of the triangle. But it's a very luminous supergiant, about 60,000 sun power, and every 27 years it dims very slowly down by about a magnitude, remaining faint for a year or so before regaining its brightness. The reason for that is it being eclipsed by an invisible companion, and we don't know what that companion is. It may well be a large star that's not hot enough to shine, but more probably it's a small star with an immense gaseous shell around it. But I won't say more about it now, because the next eclipse is not due for another 20 years at least. The rest of Auriga is quite easy to identify. It's a kind of a quadrangle. And there are three nice open clusters there, M36, 37, 38. Nothing special about them. You'll find them very easily with binoculars. Now let's look on another part of the sky and use our other main marker, Ursa Major, the Great Bear or the Plough. And you can't mistake Ursa Major. And of course, from here, it never sets. The two pointers, DUP and Merak, show the way to the pole star, Polaris, which lies within 1 degree of the polar point and therefore appears to stay almost still in the sky with everything else going around it. But take your binoculars and look first at Merak and then at DUP. And you'll realize, again, they are different colors, because Merak is white and DUP is decidedly orange, which means it has a cooler surface. Polaris, well, it's very slightly yellowish. I think most people call it white. And with a telescope, you can see it's got a faint companion, but binoculars won't show you that. But now turn to the second star in the bear's tail, which is called Mizar. And with the naked eye, you will see a much fainter star close beside it, Alcor. And binoculars show them very well indeed. But if you have even a small telescope, you will see that Mizar itself is double. And between Mizar and Alcor, there's a much fainter star. I think it's the best example of a double star in the sky. But certainly binoculars give a good view. And while you've got your binoculars in your hand against a dark sky, don't forget to sweep along the Milky Way. And you will see rich star field after rich star field. Although, oddly enough, the stars in the Milky Way are not genuinely crowded together. It's another line of sight effect. Our galaxy is a flattened system containing about 100,000 million stars. And we are almost in the main plane of it. And that's the view. But if we could look from above or below, so to speak, we will see that our galaxy is in fact a rather loose spiral, like a huge Catherine wheel. And our sun lies near the edge of one of the spiral arms, about a third of the way from the nucleus toward the edge. And the entire galaxy is in fact rotating. And the sun takes about 225 million years to go right round the center, taking the Earth and all the other planets with it. Now, of the planets, the main one visible now in the evening sky is, of course, Jupiter. And Jupiter is far brighter than any star. It's in Leo, the lion, whose main star is the first magnitude Regulus. And Jupiter is very much the largest of all the planets. It comes to opposition on February the 28th. By opposition, I mean that on that day, the Earth, the Sun, and Jupiter are more or less in a straight line with the Earth in the mid position. So Jupiter and the Sun appear on opposite sides of the sky, and Jupiter is best placed for observation. And of course it is far brighter than any star. It's also very large, over 88,000 miles in diameter, and it has a gaseous surface. If you have binoculars, you will see a small disk, and you will also see the four main satellites, or moons, Io, Europa, Ganymede, and Callisto. And with binoculars, or even a small telescope, it's very entertaining to watch those moons as they seem to shift in position from night to night. And sometimes you won't see them all, because one may be either behind Jupiter, or passing in transit in front of Jupiter, or even eclipsed by Jupiter's shadow. And of course we now know from the voyages that those moons are very strange places indeed. With a telescope, you will see Jupiter's yellowish, flattened disk. And most of you I had quite recently with my 15-inch reflector. Jupiter, of course, has a gaseous surface and is always changing. The main belts are usually more or less stable. But on that occasion, I couldn't see the great red spot, which is on the far side of the disk. But anyway, at the moment, the red spot is not very prominent. It's decidedly variable. And our best views ever were naturally obtained from the Voyagers more than 10 years ago now. And look at that lovely picture of Jupiter with the great red spot there lower down on the left of the planet. We now know what it is. It's a kind of whirling storm, a phenomenon of Jovian weather. And it may well be that the color is due to phosphorus. But it is very variable, and at the moment it's not so prominent as it has been in recent years. So Jupiter is very rewarding. But what about our faithful moon? Now, I think of all binocular objects, the moon is just about the most rewarding. And it was full on February the 18th, and therefore it's now in the morning sky and it's waning. Oddly enough, a full moon is not the best time to start observing it, because the sunlight's coming straight down, so to speak, and the craters and the mountains cast no shadows. But you can see those great dark plains we still call seas, even though for a long time now we've known that there's no water in them and never has been. We still use those romantic names: Mare Crisium, the Sea of Crises; Oceanus Procellarum, the Ocean of Storms; Mare Imbrium, the Sea of Rains; Sinus Aridum, Bay of Rainbows; Mare Serenitatis, Sea of Serenity. And that crater near the bottom, Tycho, that sends out bright streamers or rays in all directions. But of course, the moon has no water, it has no air, and therefore everything is always sharp and clear-cut. And it's amazing how quickly the appearance changes as the sun changes its angle, and the shadows shift and change. For example, look at a crater which is near the terminator, or boundary of the daylit and night hemispheres, and there's not much shadow in it. Then, as the sun begins to set, so the shadow creeps across the crater, until finally it vanishes into the lunar night. And it's amazing what a difference a few hours can make, and any binoculars will show you that very well indeed. You can, of course, look straight at the full moon with binoculars and do yourself no damage at all. You may dazzle yourself, but you can't do any harm to your eyes. On the other hand, just let me say once again, I don't know how many times I've said this, never look at the sun with binoculars or any telescope. If you do, you will blind yourself. And that's not an idle warning, it has happened. But the moon is perfectly safe. And I think you'd agree, there is plenty to be seen in the night sky with any pair of binoculars. Go and try it, and I think you'll agree with me. Meanwhile, if you want the latest information, don't forget our information line. Dial 0898 666 000, or you can, of course, dial CFAX page 626. When I come back next month, we'll be talking about the asteroids or minor planets. Until then, good night.